In this video, we're going to talk about reflecting functions across the x-axis and reflecting functions across the y-axis. The two parent functions that we're going to be working with today are y equals x squared, which is the parent function that produces that parabola, and the parent function y equals the square root of x, which produces this parabola. Notice if we rotated this guy 90 degrees counterclockwise, that would actually just be the left half of our parabola. So let's go ahead and get started. I want to take a look at our parent function y equals x squared, or f of x equals x squared. For my parent function, I could plug in these values of x, -2, -1, 0, 1, and 2, and I would get for f of x 4, 1, 0, 1, 4. What that does is that creates these lattice points. But what we're doing when we are reflecting this across the x-axis is we're taking our function, we're taking our parabola, and we are going to be taking the opposite y values, right? We're going to be taking the opposite of it. So if I have negative f of x, what that does then with my input, if I plug in a -2, I actually get out a -4. If I plug in a -1, I get a -1. If I plug in 0, 0, 0. Plug in 1, I get a -1. I plug in 2, I get a -4. So that takes these values and reflects them so that they open downward. Same shape, we're just reflecting it across the x-axis. It's the same shape, except our y values are coming out negative now. Let's look at another one. Oops. We're going to use the table for this. So order of operations says, let me put that back in. Order of operations says if I have an x value, first thing I'm going to do is square it. What that does is that gives me a parabola. Then I take the opposite. That flips my parabola upside down. Now I'm going to bump it up by 4 units. So we have multiple things happening here. I'm reflecting it across the x-axis, and then I'm doing a vertical shift. If I plug in 0, for x, I square it, I get 0, take the opposite, I get 0, I add 4. I end up with my vertex at 0, 4, which is right there. I'm going to erase these other lattice points here and declutter my picture. So my vertex has been shifted up 4 units, and I know that it's opening down because we're taking the opposite values here. It's going to have the same shape as before, except it's opening downward, bumped up 4 units. Let's look at reflecting across the y-axis. For the y-axis reflection, we're using this graph square root of x for our parent function, only now, notice instead of having the negative sign out in front, our negative sign is inside with x. This is going to force us to use the opposite x values. In other words, before, for this graph, under a radical, we can't take the square root of a negative number and get a real result. So for our parent function, we have to use these positive x values. But if I have the square root of negative x, now what this forces me to do is use negative values to cancel out that guy. So essentially what we're doing is instead of, for our inputs, instead of plugging in values from 0 to infinity, our domain is changing. Our domain now is from negative infinity up to 0. So my function, when I reflect this across the y-axis, becomes this. I can plug in 0 for x, and I get y is 0. I can plug in negative Here, I could plug in negative 1 for x. Negative negative 1 is positive 1. Square root of that is 1. And so on. You guys can do this here. Whoops. All right. Here, for this next example, I want you to look at this and I want you to think, okay, well, how could I make that 0? Because we know the square root of 0 is 0. And if I could make this be 0, that's going to tell me where my starting point is. So, what value makes this 0? That thing becomes 0 when x is positive 4. I'm starting out here. Notice, though, that the negative sign is attached to our x. Sorry, I'm really trying to erase this, and it's not working. There we go. Okay. Notice that our x has a negative sign attached to it, which means instead of opening to the right, we're going to open to the left. This thing shifted us, and now we are opening in that direction. And if you're ever not sure, one thing that always works is to make a table. I could plug in 4 for x and I get 0. I could plug in 5 for x. Now I have 4 minus 5, which is negative 1, which is not in the domain. So then I could plug in the other direction, and maybe I plug in 3. 4 minus 3 is 1. Square root of that is 1. And then I know what direction I am going in. Sorry, that's my baby. She's really cute. She's bigger than that now, though. Okay, so that's going to wrap up our video on reflecting.